If you think making UI in C++ is easy, well, think again. Because making a good looking and functional UI in C++ is hard. Really hard.
Or is it?
If you're new to the channel, hi, I'm a red robot sitting on a chair. Well, I like programming and currently I'm trying to make my own C++ IDE because I'm really bored with the pre-existing ones. I have already made a semi-functional build system for my IDE. You can check those videos on my channel. I'll leave a link in the description. Leaving that aside, for an IDE or for any desktop application in general, there needs to be a user interface or UI. A person interacts with desktop applications through its UI. So no one wants an ugly UI. Lucky for us, there are plenty of ways to make beautiful UIs for desktop applications. And in C++, we already have a handful of UI libraries and toolkits that we can integrate in our project to make great user interfaces. So, in this video, I'll explain some popular UI libraries and toolkits. Let's begin with the beast of UI frameworks, Qt. It is a cross-platform UI framework primarily for C++ but has bindings for other languages. It has modules for all UI needs and much more. It supports native widgets, networking and 3D graphics. It also supports custom application themes and widget styles. It is such an evolved framework that it uses its own meta compiler system. It even recommends its own IDE, Qt Creator, to make Qt apps. It even has its own build tool, Qmake. Qt is used by millions of people around the world for both personal projects and enterprise-grade software. To create a simple desktop application with Qt in C++, first make sure that Qt is installed and ready to use. Then set up a simple CMake project with 3 CPP files. A main file for program entry point, a header file for declaration of window class and another CPP file for implementation of the window class. In the header file, declare your own window class that inherits from QMain window class and mark it as QObject. Next, declare the constructor and destructor functions. Qt events work on the signals and slots mechanism where a widget like a button emits a signal on certain user interaction. That signal is processed by slots that are signal processing functions. So next, declare a public slot function that will handle a simple button click. In your window class implementation file, write the implementation of the constructor and slot functions. In the constructor, declare a simple qpush button to connect its clicked signal to the slot of this window class. In the onClick slot function, handle the button click by showing a simple information message box. In the main function, create an instance of the QApplication class and your custom window class. Then show that window and execute the app. In the CMake list.txt file, write some basic CMake setup code for Qt6. Now just build this project with CMake and you'll have a simple Qt6 application with a button. When you click this button, it will show a simple message box. If you want to build more complex applications with Qt, you'll need to learn a lot more about Qt ecosystem. You can do that by reading Qt's official documentation on their website. Next, let's discuss about another huge UI framework, GTK. GTK, short for GIMP Toolkit, is a prominent UI framework that is mostly popular in the Linux world. Despite its close relations to the Linux world and GNOME project, it is a cross-platform UI framework that can be used to make desktop applications for multiple OSs. It is primarily written in C but works with C++ out of the box. It has bindings for other languages as well. The ecosystem for GTK is not as huge as Qt's, but it is still able to hold its own when it comes to major UI components. It supports custom themes through styled classes and CSS. It is used by the entirety of GNOME project for their desktop applications. To create a simple desktop application with GTK in C++, there are two options. We can either write bare C code in our C++ application or use GTK's official C++ binding, GTK-MM. I'll show the classic C-style approach here. Make sure GTK is installed and ready to use. Create a main.cpp file and a bash script or a batch script if you are on Windows. In your main function, create an instance of GTK application struct and connect its activation signal to a function that will be called when the program starts. Next, run your application and finally delete this instance before exiting. In the activate function, create a simple window and a button. Connect the button's clicked signal to another callback function and add the button as a child in the window. In the button callback, simply display a message box. Then set up a simple bash script to compile your main file and output an executable. Run this bash script and you will have a simple window with a button. Clicking on this button will show you a message box. Check out GTK's documentation on the website to learn more about it and how to build more complex applications using GTK. wxWidgets is another UI library that is known for creating native widgets on each platform. It wraps low-level platform-dependent UI components into a unified and portable high-level interface. UIs created through wxWidgets look and feel native on each platform. And this is where a big drawback of wxWidgets hides. Since it is designed to provide native look of widgets and UI components on each platform, it's not possible to use custom themes in wxWidgets. Apart from that, it is very stable and extensible. It is primarily written in C++ and has bindings for other languages. To create a simple desktop application with wxWidgets in C++, make sure wxWidgets is installed and ready to use. Create a main.cpp file and a bash script or a batch script if you are on Windows. In your main file, create your app class that inherits from wxApp and override its onInit function. Then implement that app class. Next, create your frame class that inherits wxFrame and a button click handler function. Implement your app class and within its onInit function, create an instance of your frame class. In the constructor of your frame class, create a panel that will hold other UI components. Next, create a button within this panel and bind the button click event to the click handler function of your frame class. Within the click handler function, show a simple message box. Then, set up a simple bash script to compile your main file. Run the script and you will have a simple wxWidgets application with a button. Clicking on this button will show a simple message box. If you want to learn more about wxWidgets and build more complex applications with it, then check out its documentation on its website. All the other UI libraries that I have discussed so far are retained mode UI libraries. It means that they update their state only when needed. Dear ImGui, on the other hand, is an immediate mode UI library. It updates its state every frame. Immediate mode UI libraries are primarily used for making debug windows in games and other development tools, but they can also be used to make general desktop applications. Dear ImGui is a popular, feature-rich and robust immediate mode UI library written in C++. It is platform and renderer agnostic, which basically means that it can run anywhere on any platform that supports basic I/O and rendering. It supports many platform backends such as STL, GLFW and native Win32, and rendering backends like OpenGL, Vulkan and DirectX by default. To make a simple desktop application with Dear ImGui in C++, first we need to decide on which platform and rendering backend to use. Dear ImGui repository on GitHub already provides some pre-made and ready-to-integrate backends. I'll use STL3 platform backend with STL3 renderer backend for now. Make sure STL3 is installed and ready to use. I'll use CMake for this one since we have to compile a bunch of files. First off, you'll need to acquire Dear ImGui source files and place them in your project. I usually place external dependencies in separate folders, but it's totally up to your own coding style. In addition to ImGui source files, you'll also need the files for STL3 and STL3 renderer backends. Now in your main.cpp file, create a simple STL3 window and initialize ImGui. Next, initialize ImGui STL3 and STL3 renderer backends. In your main loop, listen for events and pass it to ImGui. Then initialize a new frame for STL3 renderer, STL3 and ImGui. Then create a simple window with a button. ImGui doesn't have a dedicated message box function, so we need to fake it by creating a separate window for our message box. After describing the UI layout, render the ImGui context. Finally, call functions to clean up ImGui and STL3 contexts. Then set up a simple CMake project and build it. You will now have a simple ImGui window with a button that will show a message box when clicked. To learn more about ImGui, take a look at the examples and the ImGui demo.cpp file provided within the official GitHub repository. Apart from these UI libraries that I mentioned, many other UI libraries exist for C++. Some of them are Elements, FLTK, Nuclear, AUI, and others. With such broad collection of UI libraries available to us, it's easy to get distracted and waste a good amount of time trying out each of them. To choose a UI framework efficiently, you must decide what's your use case. If you just want to make a simple calculator, full-fledged UI frameworks like Qt, GTK, and wxWidgets are certainly overkill. You could simply use an immediate mode UI library like ImGui or Nuclear. For larger projects and complex applications, choosing a more feature-rich UI library is a wise choice. So it's really up to the programmer to choose a good UI library that suits the needs of the project. I'll also have to use one of these UI libraries for the IDE that I'm making, and I have decided to go with ImGui and SDL3. There will be more videos on that later. And that's it for this video. I hope you got a basic idea about some popular UI frameworks and libraries that will help you make good-looking desktop applications. See you in the next video.